All right. Good morning. And thank you for the introduction. So, front-end development. Is it possible to do it without all the shared mutable state, without the side effects everywhere, and the accompanying gnashing of teeth? Can we get away with just pure functions and immutable data? Can UI code really be pure and simple? That's what I want to explore in this talk, and I want to start with two ideas. So, in 2013, React launched with the idea that the UI is just a function of application state. You'd write your UI as if it were rendered from scratch every time, and the framework would take care of the rest. A wonderful conceptual model. But did React deliver on this promise? Well, depends on your definition of function, but it certainly wasn't pure. The ClojureScript community quickly embraced React, and one library in particular really refined the model. Luke Vanderhart's Quiescent added an interesting constraint. He said that components do not maintain their own states and do not re-render themselves. And Luke called this top-down rendering. And this is the UI as a function of application state that I fell in love with. Anyway, so wonderful ideas. We need a Clojure implementation of it. And that's why I wrote Replicant, which is a small, pure Clojure virtual DOM rendering library. And for the rest of this talk, hopefully without interruptions, I want to show you the stripped-down approach to front-end development that Replicant was made to support, but that you could really implement with any rendering library. So I wrote a small Kanban board application for this talk, and I'm going to walk you through some of the highlights from the code. And we'll start with rendering a single task, and to do that, we'll need some data. So here is a task. And the app state also has some tags with visual styles, so you can render tags with different colors. And there's settings for each column, and of course, the list of all the tasks. To render something with Replicant, you feed it hiccup, James's wonderful creation. So we'll write a function to convert from the domain data to the hiccup, aka the UI data. And that, yeah, if you've used hiccup before, this will not surprise you. You'll have some elements, some classes. We're going to make a lookup table for the tags to render all the tags with the correct class name, put the title in there, yada, yada, yada. Eventually, you can call this function with some data, and you get some hiccup out the other end. To render this, you pass it to replicant DOM/render along with a DOM element. And then you'll be presented with something like this on screen. If you call render again with the same DOM node, but slightly different hiccup, Replicant will figure out what needs to change and perform only the necessary changes. So in this case, insert the SVG at the right place and leave everything else as it was. You know this. OK, UI elements like this typically come in a lot of visual variations. You could have a simple card with tags, different tags, an icon, and so on. And hunting down a live application for all these variations is really tedious. So I like rendering them in isolation, and I do that in Portfolio. So who knows Portfolio? OK, that's a few of you. For the rest of you, it's basically a storybook for ClojureScript. And to render an example in Portfolio, Portfolio calls these a scene. So you do def scene, give it a name, and then you give it some hiccup. And now we have this nice pure function that produces hiccup, so I can call it with some sample data, which means I can express my examples in my domain language. And if you do this over and over again, you'll eventually end up with this nice library of the various visual states of your components, and a very nice setup to work on the design part of your app in isolation. OK, so we can render a task as a card. And we even have a visual test suite to prove it. So what's next? More rendering functions. Here's the column. And eventually, we're going to take all of our application state, thread it through the top-level render app function, and then there you go. The UI literally is a pure function of application state. Technically, all we have so far is a static view rendered from a single snapshot of application state. So to turn this into a real app, we're going to have to put that state somewhere and re-render the UI whenever it changes. A DataScript database would be an amazing place to put your state, but you could also just use a Clojure atom, which is what I'll demonstrate next. So here's my main function that starts up the app. And a quick note on the naming convention that I use here. I call the immutable snapshot state, and the atom that contains it over time, store. This is how I've done it for a long time, and this is just one of many things that I picked up from my longtime co-conspirator Magnar Sveen, who you may know from one of his many projects. And in fact, the reason why I'm bringing up here is that most of the things I'm presenting today really are the results of our shared thinking and work over time, or through a lot of years. So thank you for that. He'll stick around for a little while. So we'll use add_watch then to subscribe to changes in the atom, call the render function, pass it to replicant, and to get the wheels running, we'll perform one initial swap. And now we have an app that re-renders whenever the state changes. But we don't have anything that causes the state to change. So that should probably be our next task. I'm so sorry. So I now want to add a button to this task that we can click to expand it, so you can read the description and check out the details about the task. And the question is, how can I make this button affect my state? Well, I could put a function on the onClick attribute, and since it does a swap on the store, it's going to cause a re-render. This will technically work, but it is a terrible solution. And why is it a terrible solution? Well, first of all, the store would have to be globally available, so now you have globally shared mutable state, which is a lot of fun. And even if that wasn't the case, this function, the presence of this function means that the render task function is no longer pure. Impurity is really contagious. Just a single drop and everything is destroyed. So we don't want this. Replicant has an alternative solution. Instead of the function, we could put some data on the event handler. Arbitrary data. Replicant doesn't care what you put here. But when you do, you have to tell Replicant what to do with this data when the event triggers. And we can do that from the main function by calling setDispatch, which essentially sets up a global event handler that will be called with the event data you put in your view. So I'm just printing it here to get familiar with it. We'll get a button that looks like this. If you click it, it'll print to the console. Now, what Replicant is doing here is providing you just enough infrastructure to build your own action dispatch system. If you like reframe, you can build reframe. If you want the Elm architecture, the world's your oyster. So I usually like putting in a list of actions. That's what I call them, where the inner vector or tuple represents a single action, where the keyword names the side effect I want, and then you have some attributes. Now, once again, you don't have to do any of this. This is just how I want to do it. And in your main function, you will then call on something to handle the actions. And you really do want to make this a separate function, because you want to be able to call it from elsewhere as well. You don't want to trap it inside of Replicant. And the implementation is very straightforward. Loop over the actions, case on the keyword, apply the side effect. And now we achieved two really good things. First of all, the function is out of my data, so the UI is back to being pure. But second of all, the original function could do literally anything. This version of the code has an explicit list of available side effects, and there is only ever one. And you'll find it in a central place in the code base. So with just a little bit more explicitness, you have gained a lot of predictability. And this really pays off as your code base grows. So let's see it used in practice. Here I have the path inside the state to check whether a single task has been expanded. I can grab that value. If it's expanded, I'll add a class name to the card, select an appropriate icon for the toggle button, make the toggle button toggle the expanded path, and then finally render the description at the end of the card when the card is expanded. And now, once again, UI is just data. It's fully declarative. All the mutations are centralized and out of the view, and things are just pure and simple. It's beautiful. OK. One of the benefits of pure functions and immutable data is that it's really easy to test. So let's write a test. So here I want to test that we have a button to expand the card. I'll start with some sample data, throw it into the render task function, and now we have to write an assertion. And what should that look like? We're now faced with the problem. Render task gives us the whole card, content, layout, styling, the works. But I only want to make sure that there's a button inside here. And a lot of these details, like these classes, deal with the design that really should be verified in Portfolio or something similar. And they're also quite volatile. These details tend to change a lot more frequently than the behavior because you'll tweak the design of things. So we want to make a more focused assertion, a more narrow selection. But that brings me to the second problem. This is a highly positional data structure. And index-based selection is very fragile. And tests that keep breaking all the time is no fun. The DOM also has this problem, but the DOM, luckily, also has a solution to this problem. It actually has several solutions, but one of them is CSS selectors. It's a very high-level, natural way to describe anything in this structure without being too tightly coupled to the exact structure. So I figured we should be able to do that with Hiccup as well. So I wrote a library to do that. And because I like rhymes, I called it lookup. And you use it like this. In this case, I'm selecting the first node that matches the selector, a button with a btn class. But you could also call select, and it supports literally any CSS selector you can throw at it. Almost. So then I can grab the attributes, find onClick, and now I can finally make my assertion. And now I have this wonderful small unit test that only uses pure functions that actually verifies important behavior of my UI without getting trapped in the design. And this doesn't even require complicated setup to run in a browser. You can put it in a CLJC file and run it on the JVM. You could have hundreds of these tests. It is wonderful. OK. I have my application store that contains all my data. When it changes, I call the render function, which updates the browser. When the user interacts with the page, with dispatch on action, update the store, call render, update the browser. Round it goes. This is a very nice, simple render loop with data only ever flowing one way. It's unidirectional. Yeah. So importantly, render here is only ever called for one reason, and it's only ever called in one way, from the top down. It's a very simple conceptual model. OK, Kanban. One of the important rules of a Kanban board is that you should limit WIP, work in progress. So in this particular case, you can only have 2 work in progress cards active at the same time. If you try to drag a third card onto it, you will be presented with an error. And this little toast at the top here exhibits some interesting behaviors. You may have noticed that it did a little dance as it appeared. And it will disappear by itself after a delay. And when it does, it fades out. So that's animation, transitions, and timed effects. Can we do those and still stay pure and simple? Let's see. The animation is really straightforward. It's a CSS keyframe animation triggered by a class. Put the wiggle class on, and the thing dances. So, cheating, that's just CSS. The transition is a little bit more interesting. Normally, to trigger a transition as you're about to remove an element from the DOM would require some amount of error-prone asynchronous programming with some hooks and stuff. But this is a very common use case and shouldn't be that difficult. So Replicant has a declarative solution to this, which looks like this. Replicant/unmounting is a map of attributes that will be merged onto the element as it is about to leave the DOM. You can put classes in here, inline styles, data attributes, whatever, that will just be merged onto the element, trigger a re-render, and if that triggers a CSS transition, Replicant will wait for it to play out before removing the node. And there's a similar one for mounting, so you can trigger transitions as you put things into the DOM. So in this case, because the alert class on the element has a transition for opacity, and my unmounting attributes sets the opacity 0 tailwind class, that triggers the transition, Replicant waits for it, the thing fades out. Okay, and then it is the case of the automatic disappearance. To see how that works, we have to see how the toast came to be in the first place. So when I rendered the Kanban board with 2 tasks on the whip column, I knew that if you would try to drop another card on the whip column, you should see an error. There's no more room. So that column had a drop event handler that contained this. If you drop something on this column now, I will put the marker in state that will cause an error to appear. And what I want to happen is for some time to pass, and then for that marker to go away, which will trigger a new render, unmounting the toast. So how can we do this with data? Well, we can just translate the text here to data. It doesn't say, it could have been named a few moments later, would have been more funny, but it says delay instead. So I'm sorry about that missed opportunity. But anyway, put a marker in state, schedule for 3 seconds later to take that marker away again. This will cause 2 renders and a disappearing toast. And how do you implement delay? Just call set timeout and call handle actions again. And this means that this compose is really nice as well, right? You could nest this indefinitely and make small animations that trigger every 100 milliseconds or whatever. Next case. Here I have a dynamically added form and a input field with autofocus. Now, sadly, the autofocus attribute in the browser is not reliable for this sort of use. So you will have to call .focus on the input element for this to work. And doing so does require the use of a lifecycle hook, and Replicant does have them. And it looks like this. You can put onMount on any element and do imperative things with the DOM element. But this is undesirable for the exact same reasons I said before, right? So you could use data, just like with event handlers, but I already explained how to do that, so that would be quite boring to see again. So let's explore yet another way to do this. This is my dog, by the way. She's very bored by this. So you could instead use a replicant alias. And an alias looks a lot like a function, except that you create it with def alias instead of defen. And I will hold for gasps as I show you the rest of this implementation. It's the exact same code I told you not to write. So how come this is okay? Well, that is because of how you use an alias. Def alias defines a function, yes. It also defines a keyword by which you can refer to that function. So to use the alias, you just use the keyword. So you have a data representation of it. So you could think of them as like custom tags you can put in your hiccup. And Replicant will associate the name with the function and invoke it at the last possible moment if it needs to re-render this part of the DOM. You can use this for a lot of things. It's very useful to sweep things under the rug, like tiny imperative operations, or third-party library integration. So at work, we have a Mapbox integration that looks like this. That's fully data-driven, but uses a lot of terrible JavaScript under the hood. So in some ways, you could say that this is as close as Replicant comes to components, but they can't have state. They can't re-render themselves. It's literally just a keyword bound to a function. But they can also really raise the abstraction level, which becomes evident when we look at a test. So high priority tasks should be rendered with a fire icon. Once again, I grab some sample data, pass it to my render function. But this is a future version of a render task that returns hiccup using aliases. And it looks like this. So now, a lot of the visual details, the tail-end classes, are gone. Instead, we have a bunch of these high-level concepts. It's a card. It has badges. There's a card action with a toggle button, a card title with an icon. It speaks at a higher level of abstraction. And since these are essentially custom tags, I can use them with lookup to select things. So I can select the icon that's inside a card title. And I get an icon back. And instead of getting an SVG element with a opaque path or whatever, I'm getting the name of the icon. It's wonderful. It's the perfect abstraction level for a test at this level. All right. So I showed you a form, and then I went on a tangent about autofocus. But that's not really the reason why most people use forms. Typically, you want to grab the content that people enter into them, right? So how do we do that? Well, it's just another event handler. But instead of the click event, this time it's the input event. The real challenge is, what do I put in the value position? Remember, I have to come up with this action by the time I render. But the value that should go inside isn't available until the event triggers. So how can I reconcile that? Well, when the event triggers, I will have access to the event object. So if I could put some kind of marker in here, a placeholder, if you will, I could resolve it later. And once again, Replicant doesn't care about any of this stuff. It's just data. But I do care about it. So I can take this keyword that I put in here, and when the event triggers, I can say that if I see this keyword, I want to replace it with the value from the target element of the event. And I can do that inside a post walk, which means that I can put the placeholder anywhere in the action data as many times as I want, and it will just automatically be filled in. And then you need to make sure to call this function right before you call handle actions. What happens now? Well, I can render with an action like this that has a placeholder, but by the time it reaches handle actions, it looks like this. It contains the text the user entered. So that's one input field, but what about the form? Just another event. This time, I can use the submit event. And because I use the submit event, that happens at the form level. So then I can add another placeholder to grab the entire form, just serialize the entire form. So once again, this action, by the time I handle it, becomes this action, which is almost ready to just go into the database. I just need to parse the tags. And inside your post walk, you can just keep adding placeholders. You can also use this to get the current clock time and other like impure stuff that you don't have access to at the time you're rendering. And you're probably wondering how I implemented this function. And I have bad news for you, because we have now reached the rest of the owl point of the talk. But if you're really curious, there is an implementation of this function on the Replicant website. So we just a couple of tricks then, like aliases and placeholders and creative use of data. We now have an interactive app that's still made just of immutable data and pure functions. Which takes me back to this wonderfully simple render loop. But it is a little bit too simple, isn't it? Something's missing from this picture. Most of your apps probably have back-end APIs, routing systems, and a bunch of other, what I call, supporting systems. And you're probably wondering, how do they fit in? Where do I draw this into my circle of life? That's my render loop. OK, so the solution to all of these follow the same pattern. So I'm just going to demonstrate with one, and we'll use the API as an example. So let's say I want to issue a query to the server to load some data from the backend API. That call is going to be initiated from the dispatch. But it is simultaneously going to update the store such that the render function can ask questions like, are we loading? If we're loading, we can update the screen accordingly. So I put data into the store about the pending request. It's as simple as that. And then eventually the API comes up with an answer, and it will also write data to the store. And now I can ask other questions like, was it a successful query? Can I get the results, please? And I can update the browser again. The application state is the single source of truth. It is your integration point. Everything connects to it. And the beauty of this model is that this part of your app, which I'm really underselling as render, because this will be 80 or 90% of the code in your front end, which just deals with domain data and produces UI data. This part will not need to know what routing library you're using, what backend API abstractions you're using. Doesn't care. All it cares about is data. And this ensures that your app really stays very loosely coupled. And this is really how this not only scales, but it basically rejects complexity, right? It can't get complex. OK. We're getting close to the end. I'm going to end this with a very quick demo, because I wanted to show you the app not only through slides. So I may have to make a small change to my screen setup. So here is Portfolio. And so here are the components. But since the entire UI is data-driven, I don't have to limit myself to individual components this way. I can do the entire app. So here, I have the entire app rendered in both light and dark mode when it's empty. Here it is while loading. Here it is when it failed to load, and so on and so forth. So the entire app, anything the user can see on the screen at any point in time, can be reproduced statically like this. So you can really hone in on it. And here is the app, just to prove that it exists and works, and it's not just videos. I can go like that, triggers an error. Yeah, you saw this before. Here's the cool thing I want to show you. Bloop. Here is where I start my app. So currently I'm working with some sample data that's just being swapped onto the store. If I comment out this, the app should be empty. It's empty. So I can instead fire an action to trigger a query to the server. That should fill the app with data from the server instead. So this is the server state. And now, because Replicant helped me do centralized state management, all my data is in one place. That means I can get great use out of another tool that's over here called data specs, where I can browse the application state. So here is the query loading and then success. If I go into this one, I can check out the results. I can just browse all my data inside DevTools. That's pretty cool. And you know, Kanban boards typically don't have only one user. They have more users, right? So I should be able to see what the other users are doing. So if I go back here, I can exchange actions query with subscribe query, which is going to, instead of making a request, it's going to set up a server-sent events subscription and stream data to the client instead. So we have this one, and I gotta find another browser. Here is the other browser, refresh that one, and there we go. If I now drag this over here, it's gonna be live on both screens. And I can go down here, write something. Yeah. So you get the gist. It's live now, right? And the only thing I changed was one line where I booted up my app, because the way I wrote my app, it doesn't care where the data is coming from. It only looks at what's at the store. So that was the quick demo. Yes. Right. So we built the UI from pure functions. All state changes happen in one place. Everything flows from immutable data. We have data-driven event handlers, declarative animations, and timed effects. There's drag and drop, streaming data. We have tests, visual test suite. We can browse the data. And I may not have emphasized this enough, but it's really fun. It's productive and really fun way to work. So I really do hope that you agree with me that yes, UIs can be pure and simple. And if I manage to pique your interest, there are in-depth tutorials on the Replicant website on pretty much all of this stuff. And if you want to discuss top-down rendering, you should join the Replicant channel on the Clojurians Slack. And that's my time. Thank you so much for your attention.